Hello, this is Nathan Fikes, the UTA for ME3024, and today I'll be showing you how to make this little OLED screen program right here. You can see I'm typing messages into the screen here using serial. There's also animations. There's a couple borders on the top and the bottom, and then also some text as like a logo can be made as well. So today I'll show you how to make the program and what you'll need to do. Alright, so I have the program here. This will be provided in the GitHub repository that I'll provide to everyone, as well as the Canvas page. And then also I have over here just a still image of the OLED screen. So I'll be referring to this thing over here to explain which features are being drawn inside the program. And then over here is the program. It's adapted from a bunch of examples from Ruiz Santos in the randomnerdtutorials.com page. And there's a couple things that need to be done before we kind of start. So these things here are called libraries, and they're usually not installed onto your machine until you physically install them. So in IDE, you can open up this button here. It has a couple books stacked on each other. And in here, you'll just take one of these and search for it inside the library manager. And you'll look for first the GFX library. This is a graphics core library for providing generic types of display codes for drawing on displays. So what you'll do is just find their latest version and you'll install it. I've already installed it, so I have it here. The same one here, you'll just copy this here. And then you'll have this other library, but this one is providing functions for a OLED display using this specific type of SSD 1306 driver chip. So you'll just install the latest one. And once you have those two, you won't get any errors for these two includes. The wire include should be in the standard C++ library. The same with these guys here, string, standard library, and math. You won't have to include any extra libraries for those. So once you've installed those, you can close this out. Also, this screen here at the bottom will not be open usually. So to open it, you just open serial monitor over here, and you'll get this screen over here where you can talk to your microcontroller. So the next thing is you'll want to declare some static variables on the highest level. So since we're using an OLED screen with a 128 by 32 pixel size, we can define these constants here to be this. And then we can initiate an OLED object with these two parameters. With the wire library here, we can set it up with I2C on the SD and SCL connections. And we can just set this to -1 so that there's no reset. This declaration right here declares a string called receive data. We'll use it later on in the program, but it's just a placeholder variable that will be used later on. And it's on the global scope so that functions can use it wherever needed. All right, so first of all, we'll be in a setup loop. This is not actually a loop, it's a single run. So this is where you'll set up everything. So first of all, we'll want to set up serial. We'll set up the serial with this baud here. So if you want to change your baud, if sometimes it's on 9600, so you'll just change it to 115/200 baud. Once that's all set up, you'll be able to talk to your microcontroller through serial using this message box down here. This next statement right here is a guard statement. It basically detects if initialization fails. If it does fail, it will just stall in this for loop. If it doesn't, it'll get past this guard statement, and we can just clear the display after doing that. The next thing we want to do is put in this OLED demo text on the screen before we kind of use the screen. So what we can do is we can set the text size, we can set its color. This is an OLED screen with only black and white, so we only have those options. Some other screens have color. And we can put the cursor into a location. The cursor will be on the lower left side of where this goes. So X and Y defined here. And then we can pass a string called OLED text into this display.println. So the reason why we're saying display here, we're invoking it, is to queue up these commands inside display, and then eventually we'll call display.display. It might look redundant, but we're basically saying take all these commands that we've all set up before, and we have them all queued up, and then in the display here we'll pass them into the screen, and the screen will print it out using whatever drivers we've installed here. Those things will handle how things are drawn. These are two custom functions that I've made that I'll explain in a little bit. I'll explain what they handle inside the screen here. And then once everything has been initialized, we can put a serial print onto the serial monitor, just to kind of let us know that everything has been initialized. You can see it is printed here because I do have the screen connected right now. Once you connect the screen and run it with this program, if nothing crashes, you'll get this immediately after things have initialized without doing anything to the screen yet. All right, let's get into the first custom function. So we just define a void function here with no parameters. We're just going to invoke it to do a couple things. First of all, since we're in VT, we'll just put a little VT initial right here, just a little string. We can use the same things as before. We set the size, maybe a little bit smaller, set the color and the cursor to a point up in this side of the screen. Remember that the coordinates for a screen are positive X going right and positive Y going down. It's a little bit backwards, but you'll get used to it. You can print this line up at the corner. So this is handling that little VT right there. This one draws a rounded rectangle. You can give it a initial spot to draw the rectangle, so X and Y. You can give it a width and a height, a radius for the little fillets here, and a color. So you'll see this box is drawn here using this command here. And then we can draw a black filled circle. Because we have a clock here, you can see that this box actually gets cut off because of the clock, and that's because of this black circle right here. You can put this black circle at this X and Y location on the screen, which is right about there. We can give it a radius, and it will be the backing for this clock. So whenever we invoke this components function, it'll queue up all these, and then once those are all queued up, we can then display it afterwards. I'm going to skip the clock for now and let's go to the border. So in the border, we can also put these draw functions inside for loops to have a procedural way to kind of make different shapes and things on your screen. So for instance, we'll use a draw line inside a for loop that will draw these slanted lines on the top here. We can even make this custom function here have a couple different variable types that we put in, a couple integers that kind of explain how these lines are being shifted around in each of the for loop iterations. Same thing we can do for triangles. We can have these variables be put into these fill commands that will be queued up in sequence, and it will draw these triangles in a specific pattern. So I have this triangle right here. It looks like it has 2 points on the lower side, 1 point on the higher side. So it's this first triangle. And then this other triangle right here will be the second triangle here. And I just copy it using a for loop. The next thing we want to look at is the clock. So in the beginning of the video, you've seen this little thing spinning. And this is a static image, so you won't see this spinning for now. But this custom function will handle how the clock moves. So we can give it a couple more variables like an angle or a rate or an arm length. And we can also put them inside these draw line functions. There's also a draw circle here for the clock's border. And we can have it rotate around using cosine and sine functions. And we can center the arm on where the center of the circle is. We can give it an angle to move by, a rate to erase the old line. So essentially what we're doing here to make animations is every frame, every chunk of display codes we put into queue, we want to erase the old screen and draw a new screen. So we can erase the old screen. Since we only have one thing animating, we only really need to get rid of only a single thing. So we can just draw a black line over where the old white line used to be, and then draw the new white line in a position a little bit further. That's why we have this angle minus a rate right here, and then this angle by itself. So this clock function here also has display in it, so whenever it's called, it will automatically update that part of the display. So inside the loop, we can use a little bit more things to interact with the screen as well. So the same with the clock, we have it running, but we can also use serial down here to talk with the Arduino. So here, inside this for loop, since this for loop is driving the clock, we don't want the serial to react outside of the clock's 360 angle. So that's why we just put it in the deepest nested loop, so this serial is reacting at the fastest time. If we put it outside of this for loop, it would have to wait for the entire loop to finish until it reacts to what you've typed down here, and that's really not fun for a user experience. So first of all, we ask if serial is available. So if we've typed anything down here, as soon as this is available, it becomes a Boolean true. It will allow us into this if statement, and then we'll read a piece of data from whatever we've typed into the serial, and it'll place it into P. This P is an encoded number. You can't really read it, so you have to change it into a char. This is C++ is one of its data types, so you'll just change it to a char, and you'll append it to a new variable. We've made this receive data variable as a string all the way up at the top of the program called static string, so it's something we can access inside this void loop here. And once it's all appended into there, we can get rid of continuously appending to this receive data by checking if there's a new line character, because every message we type into here will have a new line character at the end. So once all that's inside receive data, we can then do some operations on it. So for instance, we can do a check. We can say, have you typed in hello? So for instance, I can go down here, type in hello, and you'll see that you get this message. If I type in bye, we don't get that message. So we can still do some checks on the data that have come in. And it works just like a normal variable, so don't have to worry about this being encoded. It will work exactly how you expect it to be for a string. You can also change it to an int if you needed to. And what's more important is that we can actually use it on the display. So in the beginning of the video, you've seen me changing what was on the display, and that's using this receive data variable. We can do this exact same thing. We can clear the display, we can set the text size, set it to white, set where the cursor is, and we can put the received data that we've just gotten from the serial monitor through the USB connected to the Arduino UNO and print it to the OLED screen. So all I was doing in the beginning of the video was typing in random strings into here, and it would upload it to the OLED screen, updating this text here. And since we did clear the display, we can easily place back our UI components and our UI border and update the display. And since we're done with the data, we can just get rid of it by just setting it to nothing. Because if you don't do this step here, then this will keep appending to data, and this received data will just keep getting larger and larger, and it may not produce the result you want on the screen. And this is the whole program that drives the entire OLED screen. As a redirection, this is going to be provided on the GitHub page, and the canvas page, so you'll be able to access this. And another reiteration before anything, make sure you install the libraries that correspond to these two includes. If there's any other problems like with wire or with these, it's usually because it's a wrong program, or it might be a wrong version, maybe something hasn't been updated, but the main things will be these two, so just make sure those are installed. And then hopefully this helps explain the entire program driving this little OLED demo that I've shown in the beginning of the video. Thank you.